record on this computer. Okay. Well, hi, everybody, and welcome to this recorded interview. I'm joined today by Gene Humphreys from the University of Oregon, longtime professor, now in emeritus status. Gene, thank you so much for being with us today.
Sure, my pleasure.
Excited to learn from you, all of us here, wanting to learn, really our first crack at some seismic tomography. Let me try this, Gene. I want to try to share my screen real quick, just first of all show off that I know how to do this now, so I can get to this document camera. And thankfully, Gene has been watching these programs where he has a sense of where we've been this month. But I'm reminding the viewers, especially if you're brand new to us, that I'm interested in the Cascade Volcanic Arc, but I'm going earlier than the beginning of the Cascade Volcanic Arc to the Chalice Magma time, and even earlier than that. And the basic idea is, why are these crazy Chalice magmas happening? And what can we say in Idaho or even across the Western US about what's happening earlier than 53 million years ago? And we may eventually get to Jeff Tepper's rollback and break-off model. And that's the idea that we've been doing pretty regularly the last few programs. But it's really this little block in here that I'm newly interested in. In fact, I've known about it for a long time because of Gene's work, but we're really, at least partially today, going to be talking about this Idaho Slab curtain, and it looks like this. And I might want to draw a little bit with you, Gene, in just a bit. But right now, can I just get started with you? How long have you been looking in the subsurface for these oceanic plates that are now slabs? Was that 20 years ago or even more?
Even more. I think some of it goes back to my PhD time in Southern California.
Excellent. And what was the context back there at USC? Was there some new data pouring in, or were you kind of trailblazing with some of this tomography as far back as graduate school days?
Yeah, well, I was at Caltech, uh,
Okay.
and there was a seismic array out collecting data. And
Yeah.
just as a class project, I started looking at some of the teleseismic data, which means, the seismic waves coming up to the seismometers. And as
Yeah.
they pass through that structure, they're affected by it. In particular, they can arrive a little early, a little late, and we started seeing patterns to that. And for instance, there's something down here that's seismically fast. These arrivals come in early, rays come in a different direction. It kind of shifts that shadow over. So the way the shadow is projected is information on how deep it is. Well, you could formalize that and invert for the structure, and that's tomography. And that was kind of new. With Rod Clayton, we kind of developed a method to start looking at that, got the images, and then with Brad Hager, started trying to model the geodynamics of that.
What are we talking 1970s?
Yes, when late, have to think late 80s or early
Late
80s, early 80s.
Okay, got it. So I asked that decade or that time frame because there was the flat slab model, Bill Dickinson and others. And is it fair to say that you were starting to look for the slabs in the subsurface that somehow matched with some of the tectonic models that came maybe a decade earlier?
Uh, I was interested in the tectonics, but I wasn't
Yeah.
really looking for them. At
Okay.
that time, I was mostly a seismologist and
Uh-huh.
mostly just trying to figure out Southern California. Um,
Okay.
I think with time, I got more and more interested in Western US, especially since moving north.
Moving north. So you moved up to Eugene, Oregon, and were you instrumental in gathering a bunch of new tomography data when you first arrived in Oregon? Or I'm kind of trying to get a sense of how we
Yeah,
had this explosion of information 15 years ago, it feels like.
well, there were stations out when I moved here in 85.
Okay.
And students in particular went to the USGS in Menlo Park and Idaho and Montana and just started gathering data from whoever had it. Um, I think US Array kind of came across, and that was a big change. All of a sudden, we had data all over the place. Um, Before that, there were times when you could put seismic, portable seismometers out and collect data. So we did some of that, but US
Yeah.
array changed the game.
Well, I think that's where we want to go right now. So, to me, the main discovery, I know that's selling the project short, but I know the US array primarily because of that major vertical curtain underneath Idaho today. Uh, was that one of many, many discoveries, or was that a major breakthrough in understanding of the tomography in the Pacific Northwest?
Well, I think US array, that was one of many studies for US array.
Okay.
It covered the
Okay.
whole continent in Alaska.
Oh, okay.
I mean, it was a major effort. But in the Pacific Northwest, I think the slab curtain is probably the main thing. The other thing people are interested in, of course, is the Juan de Fuca slab and then other things, but those are the two main ones.
That sounds like a perfect lead in to a few of your images. I'm guessing you have a couple images kind of tied to that part of the story. I hope you do. And if you do, would you mind sharing your screen and we'll just look at a few images.
Sure.
You got down to less than 10 slides. Thank you for that and looking forward to going back and forth on those. So go ahead if you like. Nicely done. Thank you and full screen. Look at this guy. It is about, there we go.
Okay.
Excellent, Gene. Yes, please take it away. And if you don't mind me interrupting once or twice, I'll jump in when I feel like I want to get a little bit more from you. Thank
Oh,
you.
please do. And I'm not going to show a whole lot of tomography. I put some at the end. But this first slide, the main point I want to make is how do we actually interpret the tomography in the mantle?
Thank you.
And so there's a list of things, sort of a logical progression here. But
Hmm.
in the mantle, if it's more than 1% fast, it's cool. Okay. And if it's cool, it has to be made near the surface of the Earth. It's the only
Hmm.
place it's cool. That means it's lithosphere of some sort.
Sure.
Uh, and in this part of the world, away from cratons, there's a little craton here and here, but in this part of the world, uh, at these depths, it has to be ocean slab. It's the only source for that.
Yes.
So we're seeing, just like Karin Siglock looks at her high velocity anomalies, we're looking at ocean slab here.
Hmm.
Uh, the question is then how did it get there? And we start making stories. But I want to make sure people understand that these blue things we're seeing in the mantle that we're talking about is ocean lithosphere. In fact, I think since we had subduction going underneath the Idaho batholith, um, let's say 100 million years ago, this all
Hmm.
has to be Farallon plate. That's the only ocean lithosphere since that time.
Okay.
So there's lots of stories to be made here. You see the Juan de Fuca slab. Okay, that's just normal subduction. Some
Yes.
interesting structures. But in the interior here, we're seeing this feature. If we were talking about the Columbia River flood basalts, we talk about this. But I'm going to ignore that today.
Okay. Thank
Okay.
you.
Uh, Here is the slab curtain, the main part under Idaho. And you can see it wraps around underneath central Washington as well. Uh, so that is slab, and I'll show you most of my slides are more tectonic oriented than they are tomography oriented, but they're built around the idea of Dickinson and Snyder in the flat slab, uh,
Yes.
and what, kind of the telltale signs of flat slab subduction. Um,
Well,
so,
let me jump in
yeah,
right there if you don't mind. So that
sure.
are we looking at images that you started to create in the 2000s somewhere? Is that about the time frame we're talking about?
These images are more recent. I think this one was with
Okay.
2010, I think, with Brandon Schmatt. Most
Okay.
images I'll show is with Christian Stansu, which is 2020.
Okay.
They look
Well,
about the same.
yeah, well, what I'm getting at is how big of a surprise was that Idaho slab curtain? Did anybody have any inkling that there would be blue on the at that 255 slice?
Not really. In the old days, there was a station up in Newport, up here,
Uh-huh.
that the arrivals coming from the east on through it came through this and came in early, and that was just like, what's going on with those?
Sure.
That's the only clue we really had.
Okay.
Uh, Once
Okay.
it was imaged, I have to say, it was a surprise, but every time we image the upper mantle, we see surprises. So,
That's
so
good.
how
That's
much of a
perfect.
surprise can it's going to be then?
That's right. That's right.
Uh,
Okay, great. Well, you're laying the groundwork beautifully for us. Yeah, let's proceed, please. Thank you.
okay. I wanted to start with just this slide here. Here is the Cretaceous arc.
Hmm.
You're interested in the Idaho batholith. There's more to say about the Idaho batholith than just saying it's a Cretaceous arc. But
Right.
there it is, part of the Cretaceous arc. Here's Siletz, uh,
Hmm.
including the leading part. We could argue about that. It's more semantic than meaning anything else. But anyway,
Yeah.
there's Siletz. But if we look at, where'd my cursor go? There we go. The Klamaths have this big bend in them. And the
Hmm.
paleomag shows that bend as well. The Blue Mountains also have this bend in them, and the paleomag shows that rotation. And
Okay.
so, like Bill Dickinson pointed out a long time ago, that you could unfold this, and between the two, there is not a whole lot of extension. Okay, I
Hmm.
think this is from Becky and Mike there, and the Ochakos and Hornbrook Basin are in there. But you just unfold these, and you see what it looked like 55 million years ago,
Yes.
more or less. And one interesting thing, I think, especially to you, is this paleo subduction zone, wherever it really was, but close to here, is not too far from the Cretaceous arc.
Hmm.
Okay, so it's not
Hmm.
this big gap to worry about in there
Yeah.
at
Yeah.
that time. Oh,
Well, let me. So I got a chance to visit with you a number of times a year ago in August at the Penrose Conference, and we had plenty of Baja, BC folks there coming from that angle. And so I love these maps. Uh, and my mind always goes to where is Wrangell in all of this? If we are doing major Baja BC stuff, the whale has already swum north, I guess, and has gotten out of there. Is that the way you're viewing it as well, or where? How much should
you
we
know,
be wondering about the insular superterrain in these
well,
constructions?
by 55, it would be north of here, but it's a
Yeah,
bigger story than that, as you know. In fact,
right.
as a result of that Penrose conference, I think, Johnny Wu, Edward Clinnett, uh, Nick Van Beer, and myself are writing this paper about reconciling Baja BC with, some of the flat slab subduction. Uh,
Excellent.
but
Oh,
there are various options. Nothing makes good sense yet. Uh,
yes, yes. Okay, well, great. Yes, let's stay back on task here, and it is super helpful to reconstruct, get rid of the basin and range extension, get that shoreline to kind of a relatively um, accurate way to portray it on that map. And I don't know if now is the time to bring up the Columbia embayment, or if you want to do that later. But I've never known what to do with that embayment. I know you've thought a lot about it.
Uh, thinking about it is one thing. Yeah,
Right.
I could make up stories. I don't have a story I feel very confident about, but I throw out ideas.
Well,
Um,
let's stick to the
yeah.
program then.
Uh,
Yes, let's keep rolling here. This is
I know.
perfectly laid out. Thank you.
Okay. And one point Becky Dorsey here, who's
Yeah.
involved in this reconstruction, the Great Valley is sort of this fork basin. She puts the
Hmm.
Hornbrook and Ochakos in that as well, which,
Hmm.
other people do also. So it kind of lays out the subduction zone, fork basin. Here's the arc, and in between are these accreted terrains, Klamath and Blue Mountains.
Yes.
Okay, just to lay out the framework here.
Very good.
Okay. Same map. This is going back to, pre-Silesia, so I just put gray over it. Here's where I'm imagining flat slab subduction at that time.
Okay.
And in fact, we could talk more about it. I like flat slab, you see pretty much everywhere.
Yes. Yes.
And you'll see some of the logic for that in just
Okay.
a second.
Hmm.
But after accretion, I just drew a picture here at 35. It's not important when, but anyway, there's Silesia, the large igneous province is accreted.
Yes.
Cascades are just getting well developed here at 35. And so one interesting point is from the southern tip of Silesia north, we start new subduction.
Yes.
And any flat slab that was under here gets abandoned.
Okay.
Okay. From there south, subduction continued. Okay. But once this accreted, if this is subducting, this is abandoned, we have to tear the slab someplace in this vicinity.
Hmm.
Okay.
Hmm.
Once it's torn, then the edge could start delaminating. So here's the edge delaminating back, giving rise to the propagation of the Ignimbrite flare-up across Nevada.
Okay.
Whereas the subducting slab is wanting to get back to an equilibrium position. So it's close to the arc, I'd say it's more rolling back, and eventually it'll be more normal subduction, for the ancestral cascades.
Sure.
And this stuff, where's my cursor here? This stuff, we won't see it in these images, I don't think, or maybe just bits of it, but we see this in the mantle at depth now, like about 400 or 500 kilometers.
Okay.
Okay.
Well, so let me interrupt for just a second. In fact, if bonus points now, Gene, if you can figure out how to stop your share and get back to the two heads. So within that Zoom window, I think you've got that red. There we
Yeah.
go. Thank you. Now, I'm going to jump in and possibly steal a little bit of your thunder, but I feel like I'm just now starting to get the geometry of what Jeff Tepper was talking about with his model and how big that piece of material was to start breaking, rolling back, and breaking again. And I only got it from looking at your papers. And viewers, if you go to nickzentner.com and you click on Cascades in the upper right, I now have 3 of Gene's papers. A very new one that you just sent to me, Gene. Thank you. The one you did with Schmatt on the Idaho slab curtain, and even an earlier one with flat slab. Gene, if you would play with me here for just a second. I am going to try to draw something, and we'll see if you have then a couple more slides that goes in the same direction. But that last slide is very exciting to me, and I think where I want to continue to be thinking for a while. So thank you for your patience. Let's try this, see if this works. So to me, I think what I'm hearing you say is that I'm just trying basically to combine Jeff Tepper's model with yours. And that tear, oh no, let me do it this way. So if I work with Tepper and Mike Eddy and Bob Miller and them talking about this ridge subduction idea, where the ridge is offshore and we have a triple junction here and we have this ridge going in and we have a slab window. And this is where Tepper has his 52 million years ago to 44 million years ago with his geochemistry and his age progression across Washington. I couldn't figure out, Gene, if he was having his break and his rollback within this skinny little window, like within this slab window where the spreading ridge was. And I'm late to the party, but reading your work, your tear that you just described is running across southern Oregon, and you've got the tomography. And by the way, we now have this Idaho slab curtain bounded to the north by the slab window and bounded to the south by the slab tear. And then we start rolling back to the south with your Ignimbrite flare-up. But basically, is it kind of a one-to-one correlation between the size of Siletzia, the size of the slab curtain, and the slides of these two guys where we're breaking things off? Now, and I'm getting too ambitious now. Let me get back to Zoom. Stop that. Come back to
Well,
Gene.
okay.
Your reaction to that?
Okay. Well, I feel quite confident about the slab tear
Good.
on the south. I'm not sure exactly where it is, but it's kind of connecting the southern end of Siletzia to the curtain that we image. The
Yes.
pieces have moved since 55 million years ago.
Right.
So it makes it all complicated.
Okay.
The slab window up north, um, I don't doubt that there was a slab window there. I don't know that well. Uh,
Okay.
there's a lot of things we could say. We do see this, if you want, the Eastern Washington slab curtain, or whatever you want to call that, that Jeff talks about.
Yeah.
And I have to think through that more. I think the person who's thought most carefully about it is Jeff Tepper. Uh, so he's thought about it more than I have. And if I'd put my money down at this point, I'd go with him.
Okay.
He has more to say than me, but what he has
Yes,
to say seems consistent with what you just said, and as I understand what he's doing. Um, it is sort of bounding the north and the south ends of Silesia, and once Silesia accretes, we'll talk more about what happens to that flat slab.
good.
There's some options there.
Yeah.
Uh,
Well, yeah, I'm seeing more and more the significance of the Silesia accretion. Like
yeah,
it's not only explaining a bunch of igneous geochemistry in Eastern Washington, it's even kicking off your Ignimbrite sweep to the south across heading towards
yeah.
Vegas
No,
in a way, isn't it?
no, it does. If I wanted to put it in the center of the story, I would say when Silesia accretes, you've mentioned several times that you're fascinated by this big change, between uh, no magmatism and contraction, and you wake up the next morning and it's just the opposite. Everything's coming apart and it's
Yeah.
extremely magmatic.
Yeah.
Uh, uh, I love that story. Yeah.
It
What,
is. Yeah.
what happens, I think, is Silesia accretes. The flat slab in various ways starts to founder. Uh, right away beneath Montana and Idaho, giving rise to the curtain. From the tear, it starts rolling back south across Nevada. You could say the accretion of Silesia changed everything in the western
Yes.
U.S.
Yes.
Uh,
Well, I'm very excited about that currently, and thanks to those papers that you wrote. I'm sure I'm only grabbing three of dozens of papers that you've done, but it is perfectly timed for my struggle in kind of wrapping my mind around a bunch of this stuff. So great. Let's go back to sharing your screen, and we'll see how much of what I jumped the gun with there is going to show up in the next couple of slides. But yes, now I can go back to seeing. I can see that tear. You're confident with that tear. By the way, I can't hold it, Gene. Isn't that where the Yellowstone mantle plume is working its way towards Wyoming?
Perhaps
Wow.
correlation
Okay.
may not be the cause.
All right. Okay.
No,
Great.
you
Well, yeah,
know,
please continue.
uh,
This is wonderful.
okay. Let me see if I could. There we go. I want to go through a
Great.
bit of the history. A lot of people have, I've heard in your discussions, um, questioning the whole idea of a flat slab.
Yes.
I want to say a little more about, to me, the signs of it.
Good.
More than a sign, pretty strong signals. Uh,
Hmm.
I think when the slab goes flat, we know there's subduction, but where's the arc? There is essentially no volcanism. At the same time, there's strong contraction going on, which is attributed to the stress on the bottom of the plate being driven by that flat slab over that area.
Hmm. Hmm.
And the contraction typically is in the direction of plate motion, which I think is quite telling. Um, so if we just go through before there was flat slab subduction, perhaps, or maybe it's a start, and we have, the severe fold and thrust belt making this very thick crust. Uh,
Hmm.
I think that's going to get to your two mica granites.
Okay.
Okay, and it reaches as far as this blue line, then we start seeing the laramide uplifts. Okay, um,
Good.
but the point is, lots of thrusting, intense thrusting interior to the continent, and no magmatism while there's subduction. Um, okay, part two is, in this case, Silesia accretes. And when Silesia accretes, that flat slab starts foundering, and we see volcanism and extension everywhere. Now, there are different ways it's foundering in different places. Uh,
Mm-hmm.
but here, this is where we image the slab, these two pieces here. And
Yeah.
this is Christian's most recent tomography from 2020. Uh,
Okay.
and in my mind, these things are delaminating from where they were flat and rolling back and exposing Absarica, Chalice, Kamloops. So the magmatism really is a consequence. Well, when the slab was flat, the slab is between the Ecenosphere and North America, no magmatism, but it is hydrating the base of North America, all that wet stuff going down. Now
Mm-hmm.
you remove the slab and Ecenosphere upwells, decompression melts, and hits a hydrated base of North America. And that's what gives rise to this sudden pulse of magmatism, is that combination. Uh, that's sort of following Dickinson and Snyder.
Mm-hmm.
Uh, and we see slab foundering. I would say this stuff outboard of the rollback is all just rollback driven magmatism. I don't think there's any other way to explain both the curtain and the intense magmatism and the extension. These little paler pink things are all the core complexes.
Hmm.
Um, Up here, here, down here. Um, and then here's the slab rolling back across Nevada now for the Ignimbrite flare up there. Okay, so that's the sort of night and day. Uh, as soon as Celestia accretes, everything starts to founder because it really isn't happy being up on, you know, uh, up high when it's very dense.
With that concept of delamination, are you visualizing an east to west delamination, or the whole thing detaches and just starts falling and sinking together like you'd expect an age sweep that's going
Yeah,
from the Dakotas all the way back?
yeah, good question, I think. If There it is. Imagine the slab, I think, was flat all the way across most of Montana, all
Okay,
the way to Mount Rushmore, really.
right.
Um, and I talk about the Silex or the chassis conjugate underneath Wyoming,
Yeah.
all part of the flat slab. But I'm imagining it's rolling back from east. Where, where is this? From
Hmm.
east to west, and there it is, delaminated. And here's a cartoon of that. I'm not sure that's the form it took, but you see there's a chalice, and it's just coming off of Idaho and Montana. Okay, is it rolling back? Is it just the whole thing foundering in some way? I don't know. Uh, but right now, it's here. And before it got there, we had laramide, severe, no magmatism. It was flat.
Well, that makes me wonder about all the magma in the Idaho batholith that's happening during this time. You
Uh,
know,
yeah, I think the magmatism in the Idaho Bath with the arc-related magmatism,
yeah,
Basil and Rich talk about, that
right.
ended more like 95 million years ago. Well,
Okay,
that's why the slab was, well, in fact, I think the reason the arc magmatism turned off here in Sierra Nevada is the slab went flat under it.
okay,
Okay? But the crust is very thick. Much of it is quite radiogenic to boot. Um, and so with time, it's going to get hotter and hotter. The standard story for Anatexis that people develop.
mm-hmm,
So you start getting the melting of the crust just by radiogenic heating of a thick crust,
hmm,
of gneisses and sediments and
yeah,
metapelites, things like that.
sure,
Um, so, so that's what I would say most of the Idaho batholith is after 95 million years.
hmm,
I, that's what I think Basil says that, I'm pretty sure. Rich, I think, probably
mm-hmm,
does too.
okay,
The arc part of the Idaho batholith is a very western part that, Basil talks about removing it with the shear zone. Not
yeah,
totally, but much of it.
yeah, okay,
Okay,
all
so
right. Well,
um,
good. Yeah, any more slides here, Gene?
there are.
Okay,
I do want to say this little picture of this magmatism being related to extension here, which I'll say more about in a second, uh,
okay,
or this slab could actually still be going forward and down, and we're just opening up a hole back here.
aha,
Those are both possibilities. I kind of favor the second one
okay,
myself. Um, and one thing to say that I think a lot of people are skipping when they think about this, but the geodynamicists have modeled new subduction. So here is a Fairlawn slab starting to subduct. You think new subduction in particular should be very compressive, and that's just wrong. It's backwards. This new slab is hanging in the mantle. Nothing is holding it up at depth, so it's unanchored, they call it. And this whole
okay,
thing's trying to fall down, as that little arrow is kind of suggesting. So new subduction tends to be very tensile or extensional environments.
hmm,
Okay, so once we start the new subduction, the stress being extensional is what you'd expect.
huh,
Uh,
interesting.
yeah. Uh,
And when does it stop to be extensional then? Like you're saying the earliest days of the Cascades, it was extensional and then it eventually kind of becomes compressional again?
we'll get to cascades, maybe, well, not these slides, but
Okay.
once it
Okay.
starts subducting at, 53 million years ago, or whatever your favorite number is,
Yeah.
uh, then it's very extensional in what will be the back arc of the cascades.
I see.
Okay, so the slab could be pulling out or tearing apart, and it's under tension.
I got you. I
Okay,
got you.
when the
Thank you.
Cascades start, we're still an extension in the South Cascades, basin and
Mm.
range.
Mm-hmm. Mm-hmm.
Okay. Um, okay. I want to say a little bit about what's going on inside here. This is where the slab, for instance, is pulling open and exposing the base of North America. And I put this one in especially for you because you live on top of it.
Thank you. Thank you.
But this is, what's typically called the Pasco Basin. It's Pasco, Wenatchee, and even in Oregon. You see, uh, from from active source seismology, here's the images in dark. That goes back to 88.
Mm-hmm.
More recent imaging with US array and surface waves, Hayen Gao sees it even bigger than what Ketchings and Mooney saw. Here we are in the lower crust, and you see this huge high velocity area that Ketchings and Mooney, I think, correctly called a big basalt underplate.
Huh.
Okay, and so here it is, mapping this onto a map here. And at the same time, you see the Kamloops are active, Republic Graben, Tinaway, everything's extensional at that time. And a lot of these things just lead right into this area.
Huh.
And I gotta say, this is a huge volume of basalt. Uh, so that's happening in the Eocene. Okay.
Eocene. Yeah. Okay. So, wow. So totally buried by the Columbia basalts.
Yeah, it's almost totally buried, I think. Probably you see little edges of it sticking out in places.
Mm-hmm.
And they have
Okay.
drilled it in places as well.
Hmm.
Um, but it's very obvious in the seismology, this big high velocity thing down there. Um, and of course, the sedimentary basin on top of it is about as big as the LA basin.
Huh.
It's a big extensional basin covered by the basalts. Okay, which is another story I won't get into.
Right.
Uh, but at this time, we're seeing this volcanism, the big underplate. We see the Clarno lighten up, and work Ray Weldon and is working on. The Clarno or equivalents really go quite a bit south of there as well. Uh, so very volcanic. The slab is foundering, pulling open, or something in here, rolling back here, rolling back here.
Huh.
But everywhere
Interesting.
it's getting off the base of North America. Okay, so I made a little cartoon for all this going back.
I love these cartoons. I really do. Thank you.
Yeah. This is all drawn on today's map. I showed you that the coastline really didn't look like this at
Yes.
55 million years ago or 60, but you get the point. There's Farallon plate subducting. Here is the thrust faulting going on cartoon-wise for the Rocky
Mm-hmm.
Mountains.
Mm-hmm.
Up here, I'm showing the magmatism. Notice this is a log scale from 1 to 100.
Yeah.
Okay, so you see Colorado mineral belt, maybe the northernmost Silesia here, and little dribs and drabs or analytical error or something. Almost nothing going on.
Yeah.
These are the amagmatic times. Now accretion happens, and suddenly we get the Ignimbrite flare up starting. Absaricas, Challis, Kamloops. This is a big event. We're going from basically counts of 1 or 2 or 3 to up to 100 per
Mm-hmm.
square kilometer per million years.
Hmm.
So very active. And then as time goes on by 40, this is cooling off, but that slab rolling back underneath Nevada is propagating the Ignimbrite flare-ups south. And so I show here the volcanism, the core complexes, and you see by the time the Cascades are starting, perhaps at 40, you see the Ignimbrite flare-up now in the core complexes down in Nevada. Okay, and here's a little cross-section of what I'm imagining. Flat slab subduction, Idaho batholith has become quiet arc-wise. We accrete Silesia, so we have to start subduction here.
Mm-hmm.
Here is the slab that was there. It's come off in some fashion. It has to come off to give rise to the chalice. Okay, and then here we are today, Juan de Fuca subduction, Idaho curtain, looking something like this.
So, Gene, where would you put that Pasco underplating into any of these panels?
uh, sort of neglected here. Uh,
Okay.
I mean, on here, I mean, the Pasco, uh, Clarno, all that is in here, and it would
Okay.
be in here and completely not on the slide.
But am I getting hung up on the Pasco underplating? There was no presumed volcanism or magma generation during that Pasco underplating time, or
No,
maybe there was.
I think there was. I think as
Okay.
the slab was flat, and then so you're pulling it out, or alternatively tearing it apart as let's say it
Uh,
rotates, all
yeah.
that space we make, or whatever. But you're letting the ecenosphere up to the base of Central Oregon and Washington,
Yeah.
and,
Yeah.
and so to me that's the magmatism there.
Got it. Okay. Yeah. Okay. Well, I love the narratives here, and yeah, the lower right hand corner. I mean, there we go. There's our actively subducting Juan de Fuca slab, and then the Idaho slab further east, which is not sinking apparently. It's staying buoyant somehow.
That's a good question. Um, you know, I'll digress a bit, but when you take basalt out of the mantle,
Yeah.
it is compositionally buoyant. That's what
Hmm.
makes cratons stable. Okay. When you make ocean lithosphere, you've taken 7 kilometers of basalt out. And so the mantle part of ocean lithosphere has a compositional buoyancy.
Hmm.
Okay. It's also cool, which wants to pull it down. But if it's a young slab and just run the standard numbers, it's almost neutrally buoyant. So
Huh.
we have to get rid of the crust,
Yeah.
and nobody would believe the crust would stay on there in these conditions. So the eclogitic crust is gone, so that gets rid of the garnet. Um, so the slab itself, if it's old ocean lithosphere, should be neutrally buoyant
I see.
or thereabouts. In fact, the fact that it's still there, I take as an argument in favor of it being ocean slab.
So why are Carr and Siglock and others talking about this steady sinking rate for so many other ocean slabs around the world? Is this
You
somehow
know,
different?
this is different. I think normal subduction takes the crust down with it. So
Hmm.
once the crust is with it and turns to eclogite, the net compositional effect uh, is neutral, really. All
Hmm.
you've done is taken iron and garnet and put it in the crust instead of in the slab, but you
Hmm.
still have the same net composition, the same net uh, compositional effects, if you want.
Yeah.
So all you really have in Carnes slabs is the thermal negative buoyancy, as they say. Uh, in this case, we removed the crust somehow.
Got
Uh,
it. Yeah. Yeah.
yeah,
Okay. Excellent. Yes, I can see the narrative and it works perfectly for some of the stuff we've been struggling with. Thank you. Anything else, Gene?
let me see if I have. Oh, uh, well, two things real quick. Just
Good.
some of the new tomography if you want to see it. Um, here is the Idaho curtain at, down
Okay.
to 330 kilometers there, but you see different depths. Uh,
Yeah.
there's the old hinge line, worth talking about in different ways, but maybe not today. Um,
Okay.
uh, more depth slices if you just want to follow things all the way down. Well, here's the stuff beneath Nevada I was talking about that's sort of down at 400 or so kilometers. The
Hmm.
horseshoe, as we call it here. Um, and the last slide I just threw in for extra. Here's images out of a paper in 22, Lunsney and Elizabeth Miller. Uh, but they're talking about this north to south propagation of magmatism, and they're seeing
Yes.
flat slab and then the slab foundering. And in this paper, they talk about it foundering. You can follow the foundering just by following the magmatism.
Sure.
Um, and that's what they're doing. So there is the Nevada part of the flat slab coming off.
Well, yes, thank you. If you wouldn't mind, if that's the last slide, we'll go back to just chatting, you and I, but this opens up a couple other things I'm hoping to visit with you about.
Sure.
Um, if you wouldn't mind, go ahead and stop that share. Thank
Okay.
you. That was great. Thank you. I'm struggling, Gene. So here's a couple of things I'm struggling with, and then maybe I'll wonder if you feel like there are some parts of these stories that we could find some answers if we went here or here or went, whether it's tomography or otherwise. I'm trying to decide with the Farallon and the resurrection, if we want to talk about it, and the Kula. I'm trying to decide how far I want to go away from the Pacific Northwest to follow this. For instance, do I want to go all the way back to the Dakotas? Should I be finding Jeff Tepper's age progression from 52 to 44? Should I just expect those chalice magmas or I guess Cretaceous magmas to continue to get older as we go east
You know,
with this model?
uh, I'd be hesitant to be very confident in taking that story and just marching east with it.
Yeah,
In Montana, we have that alkali magmatic belt that precedes the accretion of Silesia.
yes.
And it is sort of suggesting that that slab is already having trouble before Silesia accretes. Uh, or somehow you're getting these alkali magmas out. And the slab, I don't think the slab could be at the base of Montana and have this alkali magmatism. Um, you know, um, it gets
Well,
complicated back there, Gus. You're right next to where the chassis conjugate has stopped under Wyoming and even parts of Montana. So I expect things are actually tearing there as one, as chassis conjugate is stopping, but we still have subduction in the Pacific Northwest. Uh,
so is this Farallon plate somehow wimpier than other plates? Like it seems, is it more prone to getting torn and broken? Why
yeah,
are all plates doing this? We're just not realizing it. Why is the Farallon breaking and tearing so much?
well, I'd say two things. As people image under Mexico and South America, they're seeing tears more than they thought originally. So they
Okay.
can tear, but they don't just tear willy-nilly. There's a reason for tearing. The slab kind of wants to hang together. But up here, as we accrete things like Silesia, I think the Farallon slab didn't have a choice. Either Silesia accretes and the whole slab has to stop, or the southern part keeps moving and you tear it. Okay.
Well, Silesia makes sense to me, and I am continuing to realize how profound that event was roughly 50 million years ago. But to what you were just saying, if we do have 60 million-year-old magmas or even older, and it's
Yeah.
somehow tied to disturbing the Farallon, what other mechanisms are possible? If we
Well,
can say delamination, but
what's good? Well,
what's
what I
the
would
trigger?
suggest, and I should precede it by saying we take the information we have
Right,
and we make stories. Okay.
right.
So
Yeah.
my best story would be it looks like the chassis conjugate stopped underneath Wyoming probably around 65 million years ago, just projecting it forward. We still
Mm-hmm.
have subduction underneath the Pacific Northwest. So same kind of thing. If the Farallon plate has the chassis conjugate in it, stops in Wyoming, just north of that, it would have to tear, which is starting to let it come off underneath Montana. The chassis conjugate actually extends into Montana a little bit, it
Mm-hmm.
appears. So I would say in both cases, that each tear is a result of something choking the system, either the chassis conjugate stopping for some reason or Silesia accreting.
Thank you. That helps. I will look more at that Shatsky. Uh, Another thought. I feel like I want to cross the border and start talking to Canadians. And I don't know how much you've been looking up there or talking up there. Can I chase some of this to the north? Well, it's the Kamloops magmas as well as the Chalice magmas, so there must be a
Right.
fair amount up there. What have you been thinking about, if anything, north of the border?
You know, I don't understand it that well. I try to read the papers. Uh, a different group of people work on it and different stories emerge.
Yeah,
Was the slab flat underneath southern British Columbia?
right.
Um, I would like to think so, given rise to the Shuswap type of contraction and the
Right.
Kamloops magmatism. That sounds like classic flat slab and then foundering. And if that's true, how far north do you take it? The
Mm,
Canadians don't want flat slab too far north. Um, and I don't understand all the reasoning.
right. How
So I
about a
should
couple?
say,
Yeah,
well,
go
let me
ahead,
add one
please.
thing. Um,
Yeah,
I think I might have sent you a paper I should, this paper for the Penrose conference, trying to
yes,
reconcile Baja, BC with especially the chassis conjugate subduction. If I didn't send that to you, I will.
you
Uh,
did.
okay, but it basically itemizes all the evidences, I think, for the chassis conjugate from California to Wyoming. Um, So just for your interest on that.
Well, good. I will post that. Thank you for mentioning that. I'll make sure that some of our viewers are very eager, Gene, and they want to dig in as hard as they can. And so some will print that thing out and go through it with their highlighting pens, I am sure.
It is a
I haven't.
preprint.
Okay, okay. What does that mean, by the way? I'd always feel like I'm premature sometimes. Should I not post that
You could
publicly?
post it, just label it that. I mean, we've gotten the reviews back. It was,
Okay,
minor revisions, and we're doing that.
okay.
But the story doesn't change much. It just cleans it up.
Well, I'll list it then and put preprint in the parentheses. Is that good enough?
Yeah, whatever you want.
Or I can back off entirely. I don't
No,
want to get in trouble.
you can put it there. You won't get in trouble.
Okay,
Not
okay.
from me.
Yeah. Um, where was I going to go there? I had one more thought. I think the idea of oh no, here's what I wanted to ask. This is more philosophical, I guess. Like you've spent your whole career with this stuff. Is there a certain level of frustration for you that people who are banging on rocks in central Idaho and doing all this surface geology, are people incorporating your work, or is tomography
Oh.
almost like paleomagnetic data, where people are just not even, they're like, it's not banging. If I can't bang on the rocks, I'm not going to spend much time with it. Do you have challenges like that?
Good question. I'll start by saying, I've sort of made my career out of doing my geophysics, geodynamics, seismic imaging, where I spend a lot of time uh, being interested in and trying to integrate with the geology. I think the geologists have their hands full in a couple square kilometers that I just blow by. Uh, so they are kind of ignoring what the mantle has to say, most of them. A few of them pay attention. Um, but for the most part, they do kind of ignore it. Uh, so yes, that part gets a little frustrating. But that's life. I understand it. Uh,
It seems like a missed opportunity. It's a rich data set by now. And yeah, I mean, it's to me just kind of lazy and short-sighted to just say I'm only going to deal with the stuff at the surface, because this is not just you. There's many people doing this work just in Western U.S., let alone worldwide. So I'm
well,
excited.
people like Clark Birchfield or Elizabeth Miller, there are really good geologists who listen and think about these things.
Yeah.
Uh, but day by day, my sense is most people go into the office, work hard to try to catch up, and never get there.
Yeah, right, right.
So I kind of
No,
get
that's
it.
true. That's true. Very good.
Uh,
Well, hey, Gene, I really appreciate your time. I don't know if you have anything else you wanted to add, but I felt like that was just on point with what I was hoping to do with you. Are we okay?
we're okay. And we
Okay.
can talk more about various things if you're interested.
Yeah.
Uh, but,
Yeah.
but yeah, eventually you'll get to the Cascades and I'll give you some information on that.
Okay. Very good. Well, thank you so much for your time today. I think I'm going to end our Zoom call right now, but Gene, have a great rest of the day today.
Okay. Thank you.
Okay. Thank you so much.
Sure.
Goodbye.
Bye-bye.